In 2.3 part 1, we spent a lot of time finding our zeros. We reviewed and solved, did a lot of practice with factoring, and then once we reviewed our factoring, we did a lot of solving, okay, finding the zeros. So finding where your equation equals 0. The other thing that is included in lesson 2.3 is the inequalities. So today we're going to spend just a little bit of time looking when is my equation greater than 0? When is it less than 0? Or we're going to start off with the idea of when is my equation positive? When is it negative? Okay, so just taking it a step farther, you're going to see a lot of familiar skills we already know. If you look at question 1, identify the interval on which the function y equals x squared minus 2x minus 3 is positive. So our goal is to find out when this equation is positive. Okay, we're talking intervals, so for instance, some number to some number. Okay, something along those lines. Now, in order to know where my graph is positive, if you think equation-wise, we're talking, okay, where is my graph above the x-axis as opposed to below the x-axis? Now, so with what I'm saying, yes, could we graph this and use that to figure it out? We could, but that's not the direction I'm taking us. Okay, we're going to use numbers to figure this out. So first thing I want to know before I figure out where it's positive and where it's negative is where does my graph cross the x-axis? Or in other words, where does it equal 0? And so that's what we're going to start off with, is figuring out where your graph equals 0. So I'm going to take this equation, and I'm going to set it equal to 0. So I'm taking the given equation, x squared minus 2x minus 3, and I'm setting it equal to 0 because I want to know when it equals 0. Okay, what are the steps? What do we do here? You should know what to do. This is something we've been doing in the first part of lesson 2.3.
See if there's a GCF.
Okay, start with your GCF question. Is there a GCF in this equation?
No.
No? No GCF there. Okay, so if there's no GCF, what's our next factoring step? Okay, because it is just x squared, we can jump straight into 2 parentheses. X squared we know will break into x times x. What kind of numbers do I need? Numbers that give me a what? Okay, a product of -3 and a sum of -2. Well, what are my only options for multiplying to be 3? 1 and 3. If it's multiplying to be negative, I need one of each. Which one? Larger, adding to be a negative means larger number negative, smaller number positive. So one of my parentheses is x plus 1. The other parenthesis is x minus 3. Once you have those parentheses filled in, what do we do next? Take each factor and set them equal to 0. So x plus 1 equals 0 and x minus 3 equals 0. Solve each of those real quick. If it's x plus 1, I'm going to subtract 1. X equals -1. If it's x minus 3, I'm going to add 3. And x equals 3. Okay, guys, what are these? These are the places that my graph does what? Places where my graph equals 0, crosses the x-axis. So these are my zeros, is what I'm going to say. Okay? Now, our question is to identify any intervals where my graph is positive. So with that in mind, what we're going to do is we're going to look at a number line here. Now, on my number line, I'm only going to put my 2 zeros. So the only numbers I need on my number line are -1 and 3. They don't need to be equally spaced or anything, just a matter of which comes first And that's going to be -1 comes first, and 3 comes second. Okay? And my idea here is I'm going to try and figure out, okay, each interval, what's happening. Is my graph positive here, or is it negative here? And we're going to test each interval. Now, are there other ways we can eventually do this? Most definitely. But I'm trying to get us through the idea here. Okay? So with that in mind, left of -1. What's a number that is left of -1 that I could use to test this interval? What's a number left of -1? Okay, -2. Do we have to use -2? No. -3, -4, -5, -6, -7, use any number you want. Okay, so we're going to test, what I'm going to say is we're going to test and use x equals -2. Okay, and in order to test that, we want to know, is the equation positive, negative, or 0 there? So I'm going to take -2 and I'm going to put it in my original equation. And there's a couple different ways we can do this, but so one option is to put it into the original equation. So -2 squared minus 2 times -2 minus 3. -2 squared is what? 4. -2 times -2 is another 4 minus 3. What do we know about 4 plus 4 minus 3? 4 plus 4 is 8. 8 minus 3 is 5. What do you know about the number 5? It's positive, yes? So because 5 is positive, we know that this interval is positive. Okay, so this interval, numbers to the left of -1, is positive. It's going to be part of my answer. We're going to repeat this process with each interval. Okay, so that was a number to the left of -1. What's a good number between -1 and 3 to use? We could use 1. What else could we use? 2. What else?
0.
0. Now, these are all good, yes? I love to use 0 just because it's always the easiest. Now, am I saying that I'm against using the 1? No, 1's probably my other runner-up of an easy term to use there. So, okay, plug it in. So if I plug in 0, 0 squared minus 2 times 0 minus 3. What is 0 minus 0 minus 3? And that is -3. What do you know about -3? It's negative. So right here, we know that this interval is negative. Okay? So this answer is not going to be part of my answer. And test the last interval, yes? What number do you want to use in my last interval?
4.
Okay, something bigger than 3. 4 is the most obvious choice, but again, it's not the only choice. So put 4 into that equation and see what happens with it. 4 squared minus 2 times 4 minus 3. 16 minus 8 minus 3. And here's the deal. I don't know. Do you guys have enough number sense to look at that and be like, oh, 16 minus 8 minus 3. I know that result is going to be positive. Do I have to know what those end up being? No. Okay. I mean, I'm going to put it down, but I can look at that and being like, okay, I know that's going to be a positive result. And that's all I really need to know right here. 16 minus 8 is 8. 8 minus 3 is 5. And as I said, you can use number sense there, folks. Realize once you see it, hey, I know that's going to be positive. Okay? So, you've done all the work. And obviously, I know some of you will slim down the work to an extent on your own, which is fine. Now it's a matter of what is our answer. Identify the interval or intervals on which the function is positive. Where is my function positive? What do you got?
Uh,
But what's the interval?
Negative infinity, negative 1.
Okay, so like if we're looking at this whole interval here, the left hand of as my number line goes off infinitely left, we're going to call that negative infinity. All the way up to when? When does it stop being positive? At negative 1. Where else is it going to be positive?
positive infinity.
Okay. Over here on the right end, it's positive infinity. When does it start being positive?
3.
At 3, yes? In that middle, it's negative, so I don't care about that section. But from 3 off to infinity, it's positive. Now, I'll be honest. In my notes, I have both inequalities and I have interval notation. But interval notation is what I have circled. So if I had to guess, what are they going to want for your answer in Savas? Interval notation, okay? So, I mean, we could list it as this is numbers left of negative 1, so x less than negative 1, and numbers greater than 3, so x greater than 3. You could list it like that. However, we can also just say, okay, think of this as negative infinity, yes? So negative infinity to negative 1. Now, infinities always have parentheses. What about the negative 1? Parenthesis or bracket? Is my graph positive at negative 1? No. My graph is what? My graph is 0 at negative 1, yes? So my graph is neither positive nor negative at negative 1. So I'm just going to use a parenthesis, union, and then over here, x greater than 3. So what? We start at 3, and we're going to positive infinity. Infinities, again, use parentheses. What about this 3? Again, it's neither positive nor negative, so we're using a parenthesis. Okay? Now, there are other ways to do this. I'm not going to argue that. Okay? There are ways to shorten this up, and I'll talk about some of those as we go. But the idea is being able to answer, where is this positive? We're working down to example 3, where they're going to put a less than or greater than sign in there. So knowing how to tell the less than, greater than. I'm going to list over here. I don't know if I maybe steps or just things to think about. You're going to start off by factoring, factor to find your zeros. Okay, that's the first thing we did. And something I want to comment about, notice the 0, that's where your graph turns from positive to negative or vice versa. Okay, so you're finding where the graph turns from positive to negative or vice versa. Okay, so we're finding those zeros. Another thing to comment, we found how many zeros? We found 2 zeros in this case, yes? How many intervals did that create?
3.
3, yes? So just realize that 2 zeros creates 3 intervals. I know the common mistake is to say, oh, 2 zeros, there's 2 intervals. No, we ended up with 3. And then once you find your zeros, just remember we put in test values. So pick test values in each interval. That's the final piece I'm going to write there. Test values in each interval. Okay. I don't know how many of you guys have thought, can you tell me the shape of this graph? It's y equals x squared. What have we been learning about y equals x squared? They're what? Parabola, yes? So, just for reference, that's a right side up parabola. Think about it. Someplace in here, the x-axis goes through it, right? If that x-axis goes through there, does it make sense that we have a positive piece, a negative piece, and another positive piece? Yeah. And so if we wanted to look at the graph, I mean, in a way, if you can get the graph quickly, that kind of speeds things up. But realize that's why it has that shape. Okay. Got it? Okay. We're going to practice another one. We're just going to change up the question, and I'm going to ask you to identify any intervals on which the function is negative. So, same idea. We're just looking at a negative answer. So, take that equation and set equal to 0. So, x squared minus 4x minus 21 equals 0. You got this factoring under control? Is there any GCF? No? So now what? It's x squared, so you can go straight into 2 parentheses. X squared breaks into x times x. What are you thinking in terms of numbers? Numbers that multiply to give me a product of what? Negative 21. And they add to give me a sum of negative 4. Can you do this list in your head? Okay. It's got to be the 7, 3 comment. We only have 2 options, right? Multiplying to be 21 is 1 and 21. 2 doesn't work, so no evens work. 3 and 7. After that, 4 is even. 5 doesn't work. 6 is even. Yeah. Since it multiplied to be negative, it was a positive and a negative, he said. Larger number is negative because it adds to be a negative. Put those in. X plus 3, x minus 7. And if you haven't already, what are you doing? Setting each factor equal to 0. X plus 3 equals 0. So subtract 3. X equals negative 3. X minus 7 equals 0. So add 7. And x equals 7. What are those? Those are my zeros, yes? Know that vocabulary. It's just a good thing to know. Those are your zeros. Okay. Take those zeros, put them on a number line. All I care is that you have a smaller number left, larger number right. So in this case, we're going to be looking at what? Negative 3 on the left, 7 on the right. Now, okay, pick a number to the left of negative 3 to test. What do you want to test to the left of negative 3? Negative 4. Now, question, where are you plugging that into? Did you go back to the original? Because I'm going to give you an option if you want it. Okay. The original is a good place to fill it in. The other option besides the original, sometimes the factored form is nice. Okay. You could plug it into the factored form. Now, neither one is more right than the other. They're both good ways to figure this out. Okay, so I was just going to kind of show on this one that if we take and plug into the factored form instead, it'll work out the same. We could plug in negative 4 plus 3 and negative 4 minus 7. if you went ahead and did negative 4 squared minus 4 times negative 4 minus 21, are you going to get the same answer? Yes. I'm just giving you an option here. So negative 4 plus 3 is negative 1. Negative 4 minus 7 is negative 11. And negative 1 times negative 11 is positive 11. What do we know about 11? 11 is positive, I believe is what he was trying to say back there. Now, as I said, folks, it's not wrong if you plugged in negative 4 to the original. Okay? You'd be doing 16 plus 16 minus 21, and you get the same answer. Now, pick another value. In the middle interval, what do we want to use between negative 3 and 7? I know what I'm using. I'm going to use 0. Whichever interval I can use 0 in, I'm going to use it. So if we go back to the factored one, 0 plus 3 times 0 minus 7. So 3 times negative 7, which is negative 21. And what do we know about negative 21? Negative 21 is negative. Now, with the types of equations we're doing, can you probably guess what's going to happen next?
It's going to be 11.
Depends on what number you use to test. But it could be 11, depending. And generally speaking, it's probably going to work out to be positive, yes? Okay. And there is some truth to that, but be careful. Weird things can happen. So let's see, a number to the right of 7. I guess I'm using 8. If I plug in 8 to my factored form is what I was using. 8 plus 3 times 8 minus 7. So 11 times 1, and 11 times 1 is 11. And what do we know about 11? It is positive. Okay. Thoughts on an answer? What was my question here? Identify any rules in which the function is negative. How am I going to express this answer? I have one negative section, yes, and where does it begin?
Negative 3.
And where does it end?
7.
7. Now, in terms of inequalities, and I know we're not really working with inequalities, but you could write as negative 3 less than x less than 7. However, if we go interval notation, it starts at negative 3 and it ends at 7, parentheses or brackets. Parentheses. Because at negative 3 and 7, my graph is 0. It's not positive, it's not negative, it's 0. Okay. Got the basic idea, yes? Okay. We're going to go into our bottom one. Now, the bottom one, they're not asking you to identify intervals on where it's positive or negative. They're asking you to solve the inequality, yes? Now, we are basically going to be asking where is it positive or negative. We just have to figure that out. So, guesses on what we're going to have to do first here? We're going to have to take this inequality and do what? Make it equal to 0. Okay, just think, before you do any factoring or anything like that, it's going to have to be equal to 0. So, you know, me personally, what am I going to do? I'm going to move my 3x and my 8. So I'm going to subtract 3x and subtract 8. I still like that positive x squared term. So then I'm going to have 5x squared minus 3x minus 8 greater than 0. Okay? Now what? What should you be asking yourself?
GCF.
Is there a GCF? Is there a GCF? No. Okay, what's my next step? Okay, there's that A value out front, that 5. Because that 5 is out front, you need to slip and slide. So we're going to take that 5. We're going to slide it over here. So now I have x squared minus 3x minus 5 times 8 is 40. And I'm actually, for right now, I'm just going to use equals 0. We'll come back and talk about the inequality later. Now that you slipped the 5 out of there, now what? You can go for 2 parentheses, right? X squared breaks into x times x. What kind of product and sum are we looking for? A product of?
Negative 40.
Negative 40. And a sum of? Negative 3. Make a list if you need to. 1 times 40. 2 times, see, 1 times 40, 2 times, not 10, yikes. 2 times 20, 3. 3 doesn't go into 40, 4. 4 times 10, 5. 5 times 8, 6. Doesn't work. 7. Doesn't work. And that takes us back to 8. Okay, which pair do you have working? 5 and 8. If it multiplies to be negative 40, adds to be a negative, again, larger number negative. So in my parentheses, x plus 5, x minus 8. Okay, now what?
Back at 5 in there.
Okay, in other words, can I just set my parentheses equal to 0 right now? It's tempting, but we can't because it was slip and slide, right? So we've got to put that 5 back in. So we multiply, or take it out, I guess. We multiply it in. Now we're going to divide it out. Well, good news. 5 over 5 makes this x plus 1. What about 8 over 5? Does 8 over 5 reduce? It does not. So take that 5 and put it back out front. 5x minus 8. And then you can set each factor equal to 0, right? So x plus 1 equals 0, or 5x minus 8 equals 0. Subtract 1. X equals negative 1. Or add 8. 5x equals 8, and x is 8/5. Okay. Those are your zeros, right? Those are my numbers that go where? They're going to go on my number line here. So I'm going to put my negative first, and then my positive. And let's test them. Now, with this one, when you go to test, you do not want to, you either need to use this original form here or the fully factored form there. You don't want to use one of the ones when we're in the middle of slip and sliding, because that will get you into trouble, or it could. Okay, so what number to the left of -1 are you trying? -2 maybe? So I'm just going to go back to the original. 5 times -2 squared minus 3 times -2 minus 8. -2 squared is 4. 5 times 4 is 20. Plus 6 minus 8. Again, I can look at that and use number sense and know where we're going with this. But 20 plus 6 minus 8, 18. And what do we know about 18? 18 is positive. Okay. What do you want to use between -1 and 8/5? I'm going to use 0. Okay. If you'd rather use, you could use 1. So what are we doing? 5 times 0 squared minus 3 times 0 minus 8. So 0 minus 8 is -8. And what do we know about -8? It's just that. It's negative. Okay. This is a parabola. You can guess on the next section, but I do want to talk about it. What would be a good test value to use? We had -1 here, but what's to the right of 8/5? What would be a good test value to use? Would 2 work? Yeah. 8/5. So my brain says 8/5 is 1 3/5. That means it's 1.6, or just even think 1 point something. So 2 is above 1 point something, isn't it? Okay. We don't have to test with a fraction or a decimal. Use a whole number. Make life easy for yourself. So 5 times 2 squared minus 3 times 2 minus 8. 2 squared is 4 times 5 is 20 minus 6 minus 8. I don't know. It's positive. I know that much, right? 20 minus 6 minus 8 works out to be 6, which, what do we know? Positive. Now, here's the question we need to go back and ask ourselves. It didn't say identify which intervals are positive, identify which intervals are negative. They gave us an inequality. What am I looking for here? What does that right there say? What symbol is that? Greater than? That is asking, where is this equation greater than 0? What do I mean greater than 0? What are we looking for then? Positive. Okay. We're looking for positive. When it's greater than 0, where is my equation? Positive. If it said less than 0, we'd be looking for negative. Okay, so where are we positive? We have a positive section here. How do you describe this first positive section? It is what?
Negative infinity.
Negative infinity to?
-2.
Or -1.
-1.
So 2 there. So do that.
There's lots of numbers up there. Okay. Go for the interval break, right? Not what we tested. Parentheses or bracket on the -1. Parentheses. Okay. Now, where might you use brackets today? If instead of it just being less than or greater than, it said less than or equal to or greater than or equal to, then it could be brackets. Beware. Okay. Where else are we positive? Over here, yes? And where does this interval start? 8/5 all the way over to pos infinity. Infinity uses parenthesis, 8/5 also uses parenthesis here because we're not asking about equal to 0. We just want greater than 0. Okay. I don't know that it'll necessarily come up, but I'm going to mention it because I forgot to mention it last time I taught it. Remember, if for some reason you have to multiply or divide by a negative when there's an inequality sign, that's going to make my inequality sign flip. Yes? So just friendly little reminder there. Other than that, don't get too comfortable with it alternating positive, negative, positive. If my parabola is upside down, it might start with negative. Okay? If you get something other than like an x squared equation, again, don't always just assume it'll be that order. Okay? Okay, guys, you have a little bit of time. Use it to get some work done.